Section 6, we're going to look at what is circular and periodic functions. These are actually the trig functions that we've been dealing with for the entire time with sine, cosine, really tangent, but I think we're just going to focus on sine and cosine within this section. So we'll look at finding values of trig functions based on the unit circle, and then we'll also look at properties of periodic functions at the same time. First thing that we need to understand is the idea of the unit circle. When I say unit circle, I'm talking about a circle that has a radius of 1 involved in it. Okay, and then we're really just going to focus on sine and cosine out of this. So getting us to understand this, I'm going to really make the argument that sine of our angle measure is going to be whatever y is, and cosine of our angle measure is going to be whatever x is. And to explain this, I'm going to redraw kind of this picture. So think of having a coordinate plane where the radius of my circle is going to be 1. I'm going to try and draw on a circle here as best I can. That's a really bad picture. We're going to try that over again. This is not going to be the best picture, but I'm going to do my best. So here's my coordinate plane, and here's my circle. That's better. I'm going to create my right triangle in here, and I can do this anywhere on the coordinate plane. I have a point up here on the circle that is x comma y, and I can draw in my right triangle just as I did. If I have a point x comma y on this circle, that means I went over x and I went up y units, and my radius, we said, is 1. So from the origin to this point is going to be a value of 1. We had talked about where our angle measure is always located. It's right in here, right next to the origin. So if I say sine, let's deal with sine of theta first. We know that sine of anything is opposite over hypotenuse. So y over 1, which is just y. That's the idea. That's how we get from sine of theta equaling whatever the y value is if we're dealing with a unit circle. Same with cosine of theta. Cosine we know is adjacent over hypotenuse, so adjacent to my angle is x over my hypotenuse of 1, which is just x. Again, this has to be in a unit circle though, in order to just say that sine of theta is the y coordinate and cosine of theta being the x location. And that's all they're looking for out of example 1. The terminal side of angle theta is in standard position, intersecting the unit circle at point P, which is at 1/2 comma square root of 3 over 2. Find cosine of theta and sine of theta. We just said that cosine of theta is equal to the x value of my point. The x location is 1/2, so cosine of theta is 1/2. We know that sine of theta is the y value. The y value on this point is square root of 3 over 2, which equals our sine of theta.